Hey, hi, this is Kunal, and today I am going to discuss one of the topic called name entity recognition, that is also called as a NER, and we'll also have industry use cases of NER. So basically, what is a NER? It's a name entity recognitions, and it try to identify entity from the textual data. And entity like we have a name of the people, organizations, location, dates, monetary items, kind of things. So there are, okay, so these are the some of the example we have for any year, and we'll have a case study. Basically, the case study involved is a healthcare data, and from the healthcare data, it's kind of a patient's prescriptions in which a disease and treatment are mentioned. Of course, there are a lot of other information present into the data. So we will build a model using the CRA and will for a particular disease will try to predict the solutions using the our natural language processing, and we also get that can say that it is a part of synthetic processing, which identify and classify the entities within the textual data. NER extract the information like individual, organizations, location, date, numerical value, and other things. So we have a pre-trained spacy model for recognizing the entity from the textual data. We can also build our custom NER model using the CRF, or we can also, there are other library we have like bidirectional LSTM to build the custom NREA model. So let's go for what are the application of the NER. So basically, it is a huge application of name entity recognition model in customer support. So company build an automated system that will identify the incoming, a request using the NER and send them to the respective support decks or channels. It is also being used in resume filtering, mostly used into the electronic health record entity recognition. So NER models can be used to build a strong medical system that are properly able to identify the symptoms present into the data and their diagnosis. So there are four different NER systems we can have. It's a rule-based, dictionary-based, machine learning-based, and deep learning approaches. So let's go one by one. So how can we develop a NER model using the dictionary-based system? So basically, we will have a dictionary that contain the collections, the vocabulary, and it's basically a string matching algorithm is to check whether the entities occurring the given text to the item in vocabulary or not. Then we have a rule-based system. So this model uses a predefined set of rule of information extractions. So there are two type of rules we have. One is called pattern-based rule. It's basically depend upon the morphological pattern of the word. So we'll have a different video on different kind of morphological patterns. We'll have a separate video on that. And other is called context-based rule. It's depend on the context of the word used in the given text document. Other is called machine learning based system. So ML based system use a statistical based model for detecting any entity name. So a statistical based model like we have logistic regression, decision tree, random forest, exhibit. So we can use that one. And it's a basically we have a feature based representation of the observed data. And there are two steps involved into that. One is called first phase. We'll try to train the model on the annotated document, and then the trained model can be used to annotate the raw document. And we have a deep learning approaches also. So you can use deep learning model for building the state of our NER model, and using the deep learning approach, the input data is mapped with a non-linear presentation. And what is the advantage of using the deep learning? That we don't need to manually extract the feature for building the NER. That is the most crucial step. So to build a custom NER model, what we have to do, we have to go for first part is called data loading and pre-processing. Then we have to, from that data, we have to identify the concept, what are the concept involved into that, and defining the feature for the CRF. So here we have to define the feature for a CRF. We will go into details how can we define the feature for CRF model. and getting the feature words and sentences. So basically what we have to we have a document, we have to convert into the sentence, and from the sentence we have to convert into the words. So basically this part is called tokenizations. uh, we have to tokenize into the sentence and then further into the words. We have to define what is the input and target variable. So we are going to build a supervised machine learning algorithm. So for supervised machine learning, we have to define the input and we have to also define the output. So once we have identified input and output or target variable, we will build the model. After building, we have to evaluate the model performance. We have already discussed on how to evaluate the model performance in performance metrics for AI ML models in a different video. And once we have trained the model by passing the disease, we can predict the treatment using the custom NER. And this is a very high level diagram. It's a pipeline, basically, we can say that. So we have a raw string or raw document. From the document, we are converting into the sentences, and from the sentences, we are converting into the words, and then we are extracting the POC tagging. So basically, if you go for NER application, so most important POC tag we use for a noun and pronoun. And once we have a noun and pronoun, we can go for chunking. So chunking is basically it is a kind of contextual parsing. So in contextual parsing, like we have a noun phrase or phrase and proposition phrase, we try to get those details. And once we have a chunking, then we try to get the IOB tagging. So IO means is intermediate, beginning, or other tag. We can also have if the sentence we got at the end, we have to make at the end of the tagging. Once we got that, we have to do the feature engineering. So what are the feature important for us? And then we have to train the CRF models using the CRF suite from the sklearn. So let's go through the case study. Basically, this case study that I have already, we have to identify the entity into the healthcare data. So here entity is nothing but a disease, and for disease we have to identify we have identified some disease. It's a kind of mapping of disease to the possible solutions. But there could be multiple disease and there could be some same solution, or we can have multiple disease and multiple solutions. So from that prescriptions, it's we have to identify it. So basically what we have to do, we have to build a CRF model, and using the CRF model, we have to extract the disease and from the data, and we have to identify the treatment. Okay. So they are the steps that we have already discussed: data processing, concept identification, and defining the feature for CRF, feature words and sentence, and defining input and target variable, and evaluating the model, and then identifying the disease and predictor using the custom NER. So these are the steps we are going to perform as a part of our case study. So first of all, we have to import, or maybe we also need to install some useful packages. So here we are trying to install PyCRF and sklearn CRF suite. And then once that is done, here we are loading the data into the data frame. Okay, so one thing here we are loading the spacy model to recognize the POC tagging. So there is we can use a spacy for multiple tasks. Instead, even using the spacy, we can identify the entity, but as per the requirement, we have to identify the disease from the textual data and then corresponding the solution. So this is a custom requirement we have, and for that we will build the custom model. Using the spacy here, we'll identify the POC tagging and the text. One thing I want to discuss it here, if you go for the data part, so data is not it's coming into the how the data is structured. So it could be train or test, and every word is coming into the separate line, and if it is a end of the sentence, we will have a additional slash n. So first we have to convert the word into the sentences for every group. This is the one word, and then we have a new line. Then we have to convert into the sentences. So one big, and for every word, if you check it here, so every word we have a labeling here. So cancer is a disease. O, this is a treatment. O, this is a disease. O, TTU. So D represent the disease and T represent the treatment. So cancer is a treated by chemotherapy, and corona have a COVID vaccine. So this is the labeling for that. So every individual word has one labeling. So that will help us to determine what are the disease and what are the treatment for that. So for that we will build the model. Here we have a separate file for train. We have a separate file for train label, and we have a separate file for a test data and train label. So what we have to do, we are loading the here we are loading the train data, train sentence, and here into data frame, here we are loading the train label, training label, and here we are merging the training and label into the same data frame. So we got the training data and we got the labeling here. Same things we are doing for testing data as well. So we have load test data and we have total test label, and we are here merging the test data and test label. So we'll try to understand what are the data we have and what are the labels we have. So for that, we are printing the first 5 sentence and its labels. So we can recognize that, okay, how the data we have. Same thing here, we are also doing for test data as well. Here we are counting the number of data or into the test and train. Okay, so here extract those tokens is a concept identification. So we will first explore what are the various concepts present into the data set. So for we will using the POC tagging here, and we have to extract the token like a noun and pronoun as their POC tag and find their frequency. So what we are doing it here. So we have just combined test and test data into the single single data frame or EDA as a part of EDA. Okay, so all data we are having. So total number of combined data set we are having 3,655, and here we are creating two things. We are taking the word which is a noun and pronoun and their corresponding POC tag. So we can say that data frame we have a noun and pronoun and their corresponding POC tag. So that we have converted into the data frame from our data set. So we are only interested into the text that is having the noun or pronoun. So here we are trying to see what are the top 25 most common tokens with their noun and pronoun POC tags. So these are, we can see that patient, treatment, cancer, therapy, so since it is a healthcare related data, so mostly it's a health related or disease related things, we have it. Now we are defining the feature for CRF. So we have to define the feature, and based on the feature, we are going to analyze the text and we are going to extract it because contextual information is necessary here. So what are the feature we are going to map it. So first word is lowercase, last 3 character of the second feature is going to last 3 character of the word because there should be, it can define it's a noun, pronoun or something also. And the first word is a, if first word is a uppercase or lowercase, if it is a word or is a number, if the first word start with the capital letter, otherwise 0, if it is a beginning of the sentence, or it is a end of the sentence. So these are the 8 feature we have defined. So these 8 feature 1 2 3 4 5 6 7. Okay, so we are doing for 2 word basically, one for current word and previous word. So we that help us to understand understand the context of the word. So here lower, last third word, last two word, upper is digit, and with a start with the upper. So if we are checking that if position is greater than 0 here, so we are passing the sentence and the position of the sentence. I mean it's the first, second, third, fourth. So if we have if POC value is greater than 0, it means it must have a previous word. And if it is a previous word, we are taking the consideration of the previous word as well. It's a lower, upper, or I mean it is a digit or start with a capital letter. If not, if you don't have a previous word, then so it is going to be beginning. If the POSI is matching with the number of length of the sentence, means this is going to be the last feature. I mean this is mentioning the end of the sentence. So this will return the labels. This is basically we are trying to get the one of the features. I mean one of the trend data example feature, and there, yeah. So we are trying to see one of the example from the trend data, how it is looking like right now. And this is how the feature, here we are returning the feature. So how the feature is going to be look. So CRM, last third digit, last two digit, is upper, no, it is a lower digit, no. Start with a capital, yes. So CRM is starting with a capital, yeah. And it is the beginning of the word. We are taking in random word from the last word, age. So pulse, and lower, and then we have pulse, and then it is the end. Some of the word middle. So this is how we can identify the features. Now we are defining the input and output. So get feature for one sentence, we are passing the sentence, and here we are taking the data. I mean for looking through the sentence and passing the sentence to convert into the feature for one sentence, and internally feature for one sentence convert into the feature for one words. Feature for one word. Okay, feature for one sentence convert into the word sentence list, and from the sentence list we are passing the individual word. I mean sentence list, and we are passing the positions. Okay. So once we have identified the defining the label as a target variable and other part as a input variable. So we are using sklearn, so we have to pass number of iteration we want to perform, and then we are calling as a CRI fit model. Here we are, if there is any exception occur, it will handle the exception, and we are doing the predictions here. Now we have to evaluate the performance of the model on the test data. So we have passed the test data, and we are using the F1 score. So since it is a classification problem, so accuracy is not always a good metrics to evaluate the performance of the model. So F1 try to balance both call precision and recall. So where precision and recall both are important, then we have to go for F1 score. So we are able to see is 90% of the accuracy is correct. So that seems a very good model for us, and we can go ahead to predict the the treatment for the disease. So for that, let's try to validate the result by predicting the level and actual level. So this is how we can get it. So we have to identify the disease and treatment using the NER. So we have to build one custom model, create a logic to get all predicted treatment level for test data. So what we have to do that, we are passing the test data and we are checking the length of the predictions for that specific sentence, and for ID into the range. So basically for one sentence, two sentence, three sentence, it will go through the loop, and for each of the test data, so we are trying to extract two things here. One is a disease and one is a treatment. So how we are going to identify disease and treatment? We have marked has a disease and has treatment as a false, and this is the find disease. This is the disease we want to find, and we are taking the data like for that a specific sentence from the test data, and for range in the length of that predictions level, like if you go it here. So for every sentence we are having the, let's go it here. So you can check that, right? This is the length. What is the size of the data? So we have built a model, and so if we see that if y prediction of id, this is the sentence one, and this is the position of the word into the sentence, and this is called basically a label. We are trying to verify the label first. So if y prediction of that particular word for that particular sentence and that for particular word is labeled as a d, I mean it's a disease, so we are marking as a disease, and we are storing that disease name from the test data. Here str is nothing but test data into the where digit. Similar things, let me go here, we can also see that these are the other. So yeah, we can see that. So this is a D and this is a treatment. So if it is a T, it means it is having some disease, and if it is a mark as a treatment, that will describe that it is a treatment things. So same thing we are trying to extract from here. So we have identified if that particular word label is a D, then it means have a disease, and for that particular position we are getting the word into the where disease. Here we are checking the predictions. If it is a tree, I mean there should be a treatment, and from that we are extracting the treatment data for that particular words and checking if both is true, I mean has disease and had treatment is true only, then we are appending into the disease and we are appending into the treatment. So disease is a one list and treatment is a one list. So once we are done with the disease and treatment, so both here as a list, we are creating a data frame. Okay, so we are creating a data frame. So once we have a data frame, that will talk about the disease and their corresponding solutions, I mean treatment. So it's unique here. There might be some possibility we have a duplicate data, so we will remove the duplicate data, and so once we have a duplicate, yeah, it's a total 110, and then after removing the duplicate, we are left with a 103 data, I mean rows. So here we are trying to see if what is the treatment for disease, this one. So we are got radiotherapy. Okay, so this is the our NER model, and we are able to predict the treatment for the disease. So I hope you have liked today our video. Please like and subscribe and share so that we can reach to the multiple people. Thank you.